Okay. Recording begun. So give you okay here. So just a little bit of introduction. So why creating architectures? Where are we going? So one thing important is that software, different from hardware, is something new. If we think about engineering has more than 100 years, and software is relatively new. If you think on the time other technologies, other sciences are there, software is hard. Ironic saying, but I mean hard because it's abstract, is subjective, and so software it's difficult to put rules, definitive rules. I mean, just an example, if you have, I'm so sorry, if you have to build, you know, an IoT system to control your house, there's no gray areas, it's the hardware is there, the signs, the signals are there, you connect the components and that's it, and it works. And now software, you can make things work in 1,000 ways, and you have to think about and how we're going to use these algorithms, how you're going to think abstractly over this. And we need to be organized. What, as I say, other areas of engineering, like when you build, when you build a bridge, organization is kind of already there. You just can't, build the bridge before you put the main support. So it's always there. You can't miss. But in software, you can do several things that by the end you see that doesn't work. Now, so my intention here is to show you, and I think the best way to understand architecture is to understand how we got here, how we got to the architectures we have today, and why we got here. So that's why I'm going to give you a very quick historical tour. And during this time, since I'm very old, as you can see, I'm going to try to bring my experiences along these decades to illustrate my point of view. So let's begin talking about that. So this is an idea of how things changed a long time since the 80s. How systems were more distributed, or the size of the projects has been changing. We had small projects, then began to have big projects, then small projects, and more things. But let's go begin with the 80s. So in the 80s, we had the main architecture there, what we would call, let me put between question marks, monolithic architectures, and that's not the correct way to say to define monolithic. That's today's definition. But the idea is that we had everything in one software, in one program, and we had no networking. So there was no way to connect with other systems. So distribution was not an issue at that time. So what kind of architectures we have there? Console applications, like the little black screen on where we create something and you just by the command line say what you want. One of the other architectures we had at that time was what we call the event-driven. Like you have a code and you create a code that responded, for example, to the press of a button. And there was the beginning of some client-server architectures, but they were completely non-standard. I mean, there's not something like HTTP like you listen today. Every server had its own protocol, its own way of communicating. So it was kind of a mess. But the beginning, and as I'll say, the beginning of a solid architecture at that time began with the war between procedural uh, um, the procedural paradigm and the object-oriented paradigm. Nobody discusses today about object orientation, but by then, in the 80s, everybody said, well, object orientation was never going to work for several reasons. People wouldn't want to change to object orientation. And there was kind of a war from the people who defended object orientation, mainly because of the modeling aspect, because object orientation allowed us to the first step in architecture. The first step in architecture is modeling, is you organize things in a way of each module, each piece is responsible for something, and they interact with each other. So object orientation came as, like, say, a baby architecture. You know, architecture began as a baby with object orientation. The famous kind of Bible of software engineering from Pressman, the first edition was in 1982 when he began to bring up all these issues. Now, I'm going to get to you some personal experience. Exactly in the 80s, actually by the end of the 80s, I began to work in a project. The best translation is GIS API, that was a geographic information system for epidemiology analysis. And so that was my first big project. And at that time, it was a small project. I mean, not big, team. It was a desktop application, you know, no internet and everything. But at that time, I began, and I worked on this crossing the 80s to the beginning of the 90s. It was, you know, a long project. And in that project, I began to apply the modeling of the object orientation. What gave a lot of possibilities, for example, to expand new functionalities for the user. But again, that was the beginning of the architecture. And say, well, okay, that's something. And then we had some problems. We had some questions from the customer. What are you going to need to process this function here? Well, sometimes I didn't know because the architecture was not well defined. How could I incorporate new modules? Well, not so easy. I had object orientation, what made it easy, but we didn't have a lot of strong architecture definitions. The most terrible one, like, could you change the behavior of this button here? And I would say to my boss, well, it will take some weeks. I just want to change this button. Oh yeah, but the business logic is integrated with the button. And you see, that's why we did not have a lot of rules for architecture. If I had designed it, and of course I was new on that, and if I had designed the architecture the proper way, the business logic would never be in the button. It would be somewhere else, you know? And other things like, well, it's not working on my machine, but works on mine. And again, that was the problem of compatibility. All these things um, tend to be solved by a good architecture. For example, compatibility, what's the problem of working on my machine and not working the other, is a part of the domain of the architecture. Compatibility. You have to, that's a no functional requirement that you would have. Modularity, if I had to think, if things were more modular, would be easier for me to expand, extensibility. Everything on this could have been way better on this project, even so, I got some prizes with this project. But again, it has 30 years and architecture was just beginning. And that's what I want to show you, how a good architecture, can change a lot of things. Its importance. If I had the knowledge of a good architecture, then a lot of better things could be happening. Now, things moved on to the 90s / beginning of the 2000s. Things moved different, from different countries. But then the beginning of the client server and distributed architectures began with the idea that, well, I can run my applications in the server. Or in other words, I had connectivity, I had network now, I had internet now. So I can run my applications in some place and communicate with these places. A good example, well, I can have a shopping place and I can place my request, and I, put my credit card, and I can buy things. It came later, but basically that was the idea. And well, then came a problem, because every source wanted to create its own server, its own way. And so if you create an application for some company, you have to, prepare the code all over again, and so on. So came what we call application servers. Actually, Sun, that doesn't exist anymore, but Sun and IBM at the time, there's a story of a real war between the two. If you don't know, a curious story, but Sun was leading the Java. They kind of created the Java, and IBM came with Eclipse. And if you pay attention to the names, you know what Eclipse means, right? Get over the sun. So the idea of the name Eclipse, well, that's what somebody inside IBM, I was working there at the time, the idea of using Eclipse was not, coincidence. It's because they wanted to do something, to eclipse Sun, because they were competing at that time. Microsoft was beginning with the .NET framework, and the idea is the hope, and let's put hope in the strong words there, in strong caps there, and the hope for compatibility. Okay, let's create something that can run in any server, because in theory, all application servers should follow as a standard. And if I create an application, it should run on IBM WebSphere application server, or it could run on WebLogic. So in theory, they could run. Compatibility is a wish, never 100%, but it went well at that time. And again, it was at the beginning of the 90s, and then this knowledge was beginning. And another point of architecture begin to, let's say, an issue arises at that point, and that is what we call fat or thin clients. For the ones of you who could not know about this, here's the thing. If you have a web page, and by that time, or if you have a web page and you click a button, and then you have to wait for everything for anything that this button does uh, to go to the server, be processed, and come back. That's what we call thin clients. Thin because nothing is happening in the client. Everything is happening in the server. So things like I click a button and then open a dialog box and I write something and everything is happening in your computer. It's not going to the server. So these things is called fat clients. I mean, there is a lot of things happening in your client, in your browser. So there was a kind of war there or a competition there, like, okay, we do fat or thin. By that time, since we have been coming from the desktop applications, because that's where all the things began, and that's why I keep saying, understanding history is important. There was a trend for doing fat clients. What was the problem with fat clients? Well, first of all, every time you wanted to work with that, we had, a download that could take time. Internet was not fast. The other thing was compatibility. So not every browser runs the same thing. And at that time began also the multi-tier architectures. Let me go to an example instead of talking all this. One of my projects, again, we finished in 2003. As I said, things cross years and decades, but it's kind of all originated in the 90s. Project Sara was a very big project in Brazil for you imagine you go to the post office branch and there is a computer there is a a person there, and you want to send a letter, and you give the letter to the person puts some stamps and do some stuff and fill something on a terminal, and then your letter is sent. Well, that was the system, and the system was supposed to be all integrated. Brazil has, just for you to know, Brazil has four um, time zones. We have four. So several problems we had with these projects, for example, synchronism, because when some branch was closing or opening in the first time zone, the other one in the fourth time zone was, already closing or has not begun yet. And we had to have a server to deal with all that, because we had to close, uh, all the financial stuff and things like that. But anyway, so there was a lot of problems regarding that. This system, as I was saying about the fat clients, originally was done with the architecture of fat clients, because since they were branches and we did not want to go to the server every time, imagine that Brazil had 2,000 branches, each branch with about 5 to 10 terminals. You do the math. The number of terminals would be going to the server every time. We did not have network or power, not power. I mean, we did not have performance to do that. So the client should have to be fat, and things had to be done locally and then reconciliated with the server. That was a great challenge there. Not all that, but we had several languages. I mean, we had Java for the code, we have C++ to control devices like the scale that will weight your letter or your package, for example. And so we had to deal with that. And we also had in the database several storage procedures, internal procedures in the database, doing several business logic to process the data there. So imagine heterogeneous technology, distributed architecture, reconciliation techniques. We used some design pattern orientation. I mean, the code was designed to be as much as modular as we could. But we did not have yet scalability, for example, as you could say, and that's another story I can tell, is that when we deployed the first branch was kind of, as you imagine, some politician came there, to cut even so it was not, well, it's a kind of private and government project. There was a politician there to cut the ribbon and things like that. And then they pushed the button, okay, begin, and then 2 hours for the thing begin to work, because it took 2 hours to download all the code, all the fat client there. So that was a terrible problem. The system was not scalable. IBM had the commitment to just deliver 10 prototypes, and the rest was done for another company, and they had a lot of trouble, changing all that to create scalability. Now, why I'm telling you all that? So let me, oops. Why I'm telling you all that? First of all, where is the business logic? Well, part is the front end, because of the speed that I was telling you. And that's a problem when you have to change things. The front end, the front end is not where you put the business logic. Also, business logic is spread in the database. How we can change hardware interfaces, since it's all integrated with the code, in every branch. Why it takes so long to open the branch, as I just tell you, how to reconciliate, for example, if you're using the same scale in the branch, we have to deal with multi-threaded distributed architecture, where it's very hard to do. So now, what is the problem here? How it could be improved, how it could be way better, again, with architecture. If we had used several techniques that came later, in our defense, because we were a big team, what could we have been done with modern architecture to not have all these problems? Again, architecture, a good architecture. First of all, modeling. In the modeling, you have to divide the responsibilities. One of the very known patterns of architecture is the model view controller. Let's separate responsibility. In other words, the front end is never the place to put business logic. Modularity. So let's separate components that will talk, for example, with devices, then components that will talk to the business logic. The distribution. I mean, where I am going to deploy every module. All that is defined in the architecture of your system, folks. So again, it's not documentation for you to do at the end of a project. It's the first thing, and it's critical. So technology is what we call non-functional requirement. It's again, it's the part of a project development, and it's part of the technology. Um, I hope I begin to, I'm convincing you more how IT architecture is important. It's important to know how to do a good architecture. You may not become an architect, and then began we still had a lot of web architectures. Then we began with the service-oriented architecture. What's basically, um, let me put this way, the traditional service-oriented architecture has a lot of particular characteristics, but even if you are not doing a pure service-oriented architecture, the service-oriented architecture was kind of a base for the distribution in the good architectures that came later, because it helped to decouple things. One of the good secrets to a good architecture is the separation of responsibilities, is the separation of modules, for you to be able to do a good reusability, scalability, and so on. Again, another example. I think examples tell more than I go than I go each item here. So that was one of my great projects. I was at IBM, and that was a very strategic problem because it was a planning system for maintenance in IBM. And since IBM has an incredible base of machinery, hardware, the maintenance is kind of, they used to say that the maintenance uh, uh, revenue, sorry, the maintenance revenue of IBM kind of pays, they used to say it pays the light, pays the basic, pays people, the rest of the thing is for investing and things like that. But is the pays the basic there. So it's extremely important for you to plan everything, and know how much resources you're going to need next year and the other year, how much you expect to receive from the maintenance contracts and so on, pieces and so on. So that was a big project. Like I have to say, was a multi-geographic um, project. I had my team, I was the main architect of the system, and I have a kind of 40 to 50 people along India, China, Mexico, United States, French, Brazil, and a couple other places that I don't remember now. So it was very spread and a very big project, as I said, very strategic. And the idea was to migrate from a legacy system to a more modern distributed web application, and using also some service-oriented architecture. Now, in this project, now were mature to use a more consistent architecture and development methodology. We have the rational unified process. In IBM, we have a variation of the rational unified process. Well, IBM bought rational, so they have the liberty to modify. They call global service method. What's pretty much the rational unified process. So, and then some of them remember that I said there was a war between the thin client and the fat client. So we were in an era, no, era, an era where um, the thin client was, winning. The J2E framework that was based on this system, we used what you may have known as servlets, JSPs, HGBs, and things like that, part of the J2E framework. It was pretty much server-based, and the client were thin clients. I mean, the little as possible in the client, the little as possible that runs in your browser, and everything was processed in the server and getting back to the browser. That's what we had at that time. We also have multiple tier architecture that also divides responsibility, like, okay, front end is here, back end is here, and things are separated. And if I want to change the business logic is here in this tier. We have a very consistent methodology. So one of the important things here was the end-to-end process of development. Now, let's go to the problems, and let me give you why all this architecture stuff that we used here solved this problem. So then we had the questions from the customer and everywhere. Well, what's so hard to raise the business rules? Well, I mean, to discover which the business rules are. Well, legacy systems. So we had to sit behind a very old employee of IBM that was almost going to retirement, explaining verbally how he did things, because there was no documentation. Then you see, how important is a whole project development and architecture system. So it was a nightmare to get all the knowledge from these guys. There was travels, we had to go to where they were because they didn't want to travel, and so on. Again, why is it taking so long? Well, that's the problem. When you have a very big system, and it's not usual nowadays, we have to make sure every piece is connected, that nothing is missing. So, and it has bad sides and good sides, but one of the reasons is that every change, we have to review everything. So it takes more time because we have to think through every problem, not to make sure nothing is left, nothing is forgotten. Why can't you just change a simple thing and deploy? Well, because there is a process. You just can't go on the code, fix something in, and expect you're not going, that you did not mess everything. So I have to test everything again. Why can't I just add this new function here in the front? Again, we can't mess with the architecture. Everything is well planned. Now, again, then I bring my architecture here and say, look, here's what we got. And for the good or the bad, we have a methodology. And the methodology makes sure that we are doing what we're supposed to do, that we know what we're doing. And architecture gives you that. Here's something that people don't like. People don't like it today, but still big projects today, they are following these rules yet, because you see, architecture coupling is coupling with requirements. So if you want to change something and people complain, well, I want to change this thing here because I have a need here and something changed and then I need to change this thing here. Well, okay, it's not we're not saying you can't change, but one of the real points of architecture is that the architecture is totally integrated with requirements. It reflects what the client decided in the beginning. Okay, if you want to change the requirements, go back there. Okay, that's fine. But you just can't go to the architecture to say, okay, I want to change this model here and that's it. No, because that model is tracked with the requirements in the beginning. That's part of the methodology. So that's why it sometimes takes time. So that's why it's not so easy to change things. But there is a good reason for that, for you not miss a requirement. Folks, listen to one very important rule. Requirements is the most important thing in the system, even more important than architecture, because that's what we are doing. We are fulfilling a requirement of a customer. That's what we all doing. So that's the most important thing. Okay, bureaucratics, but leads to quality. So sometimes you just want to change one bug that you detected and you want to say, oh, it's just that this small uh, line here that I just want to change here. And you say, oh, okay, I just changed it, go to production. No, you can't. You have to have strong testing procedures. If you change something, you have to go back and go to your system test, integration test, etc., to make sure that it happens by mistake. You just typed something wrong in the keyboard, and then you messed everything. It's not on purpose, but happens. So strong test procedures leads to quality, ensures quality. So people don't like this bureaucratic. There is, and I know that the new uh, management process methodologies like agile, they tend to say, oh, okay, you have to change, you change now, and if there is a problem, we fix later. Well, that's a methodology, but we are at that time, we for sure, I'm not saying that's right or wrong, but we have to understand that when doing that, you are opening, let's say, for a possible decrease in quality. Architecture decisions, folks, that's one of the most important things that, again, you have to put in your mind. Architecture decisions make which will save your life and perhaps your job. Everything you decide to do in a system, even if your manager says, put it there because I'm the manager and you have to put it there. It happened to me. And you say, okay, you are the boss, fine. Then you go to a template that exists in every methodology that's called architecture decision input. Well, that were the options. The options were this, and we decided this one. And you can say, well, I do not recommend this decision, but that was decided by the management, and that's it. Because if things go south, as we say in English, I mean, things go bad, you're going to say, well, it was not my choice, and that was documented here, and that's it. So pay attention to that. I'm going to talk a little bit, again, I'm just going to talk to you a little bit about the new architecture, for example, hexagonal architecture that's was the beginning of the 2000, kind of 2005 to here. It's people are talking more about this right now. And again, everything is an evolution. Hexagonal architecture, it came to solve a problem that, remember that I talked about, changing things, it's hard and so on. So hexagonal architecture came to the sole purpose of isolate business logic from everything else. So the idea, okay, it's more than that, but to be very, to make it simple, the main point of the hexagonal architecture is that the most important thing in your system is the business logic. And well, if it is, and let me put an if here, because not all systems is business logic oriented. Of course, all systems has business logic, but if you think about, for example, a system that is just for entering data. I mean, I'm just gonna get several students and put on a database. I'm gonna just put an entry system. Okay, it has not so much business logic. It's but basically accrued. You know, it's basically a system that access the database and put data there. There's not so much business logic. So make no sense an hexagonal architecture there. But if you're thinking, for example, HR systems that process your payment for a large company, there is a lot of rules. I don't know in French, but in Brazil, oh, there's a lot of taxes and rules and changes every time. So the business rules are very complex. And so we have to protect this and make sure, you know, it's all working fine and it's not dependent on everything else in the system. And if you have to change something, it's just in one place. Now, for these kinds of systems, an hexagonal architecture is a good solution. For example, in my system that I just described for the maintenance and planning system, the business logic was very complex. To use an hexagonal architecture back then would have been an advantage. Unfortunately, this kind of architecture was not around when I was doing this. Even so, people like me and other architects use it to, by, let's say, instinct or experience, to follow the same guidelines. We try to separate business logic from the other parts of the systems when we did this project back then, you know, as much as we can. Even so, I cannot say we use the hexagonal architecture. So that was the beginning. As I said, you know, the baby hexagonal architecture we tried to implement there. One of the issues I'm going to bring to you in 1 minute is that hexagonal architecture has one very important fragility that has to be in your minds. It's very difficult to separate the database from the business logic. And hexagonal architecture tends to think that all the business logic is in the central code, and the database is just for persistence of data. And it's not true. Database has business logic too, and reconciliate could be a challenge, okay? Again, I'm gonna say what I have been saying since the beginning. All this that I'm talking about to you right now, it's not something that comes to your mind when you just open your development IDEs and begin to code. It's difficult because you tend to just program what you need to program. So architecture, looking to things to architecture point will give you all these insights before you begin to write any line of code, you know, and all these problems will arise and you can think about it and come with the best solutions. Just a little more, from the 2010s to now, we came to the microservices architectures. Microservices architecture, what's pretty much a trend right now. And I am going to give you two important things here. Came to a lot of folks are saying we have to kill the monolithic architecture. Monolithic architecture should be banned, and everything should be microservices and so on. Well, let me tell you first one thing. Monolithic architecture, it's not a desktop architecture. For example, a 3-tier architecture, you know, a simple web application like, you know, eBay, let's put it this way. eBay is a monolithic. Well, I do not know what's beside that, behind the eBay, but something like eBay. I mean, like an e-commerce where you buy stuff, put in your shopping cart. This is the monolithic architecture, folks, because monolithic doesn't mean all the code in one place, and it's not like that. The idea of monolithic is not that. The idea of monolithic is that you don't have modules that could be separated and executed separately. That's the idea of monolithic. And sorry, that's the idea of the microservices. But monolithic, uh, you an e-commerce site is monolithic in a sense that you can just put the shopping cart out and it's not going to work without the rest. But even so, it's a distributed system where pieces are in different places. So it is monolithic. Sorry, sorry for the ones hating monolithic architecture, but don't confuse monolithic with old desktop stuff because that's not the same thing. Okay, the main point of microservices architecture is how you sever the system down to the smallest independent cells. I mean, I want to run all this business piece here and not care about anything else, and this thing can run independently. Well, it's easier to say, harder to implement, okay? Because you have to understand very well your whole architecture. And again, I go back, if you don't create your architecture very modular, very, if you don't understand very well your architecture, your modules, your components and everything, harder will be for you to move to a microservices architecture. Again, microservices just not say, okay, I'm going to put everything in 7 bags and that's it. No, it's more complex than that. And it requires, another presentation, and I'm going to just move on. And we have now evolved to the clean architecture, what's towards the hexagonal, but with more separation of responsibilities. Cloud systems, well, it's basically SOA, but now we have to go back to thin clients. You have serverless architectures. That's the area of blockchain architecture. So I'm just giving you what we have by now. And as a conclusion, I just wanted to go back to the very beginning. So for we to wrap up. So as I said at the beginning, it's important to understand where we came from, where we're getting here. And that's a very simple graph that I did. And you can see that in the very beginning, most things were more question mark, monolithic, more desktop. Projects were large. Clients were fat. And right now, we have things that are more distributed. The clients now are not so thin and not so fat, but they are adequate to the necessary. Projects, again, are not so small, not so large. They are beginning to stabilize in the necessary size. In the tiers, well, we still have the 3 tiers or 4 tiers architecture. If you look to the graph, you're gonna see, for example, that the project size began small. They got, let's see if you can see my mouse. Oops. They began to be big projects. Now they are getting small again, but stabilizing in a reasonable size. The only thing that has been growing is distribution. Distribution is, the main point, and I think it's rare that this go back. We never know. The tiers, as I say, the number of tiers for the architecture, it was very small. they begin to have more tiers, then stabilize it again in the reasonable size. The fat and the thin clients, again, they were fat, then they were very small, then they got a little bit fat again. So you see, there is some convergence nowadays to the more reasonable of all technology. I mean, let's see what's reasonable. Not everything should be monolithic, not everything should be all distributed on microservices, not everything should be a big project or a small project. I think, as my perspective, architectures are converging to something more reasonable. And the question that I leave to you is it possible to go all this journey just on development, just coding, without the architecture eye and comprehension? You saw all that, you know. Could you understand? Could you get here without looking to the architecture perspective? I leave you with the question, and that was my purpose here to, leave you with the question in your mind. If there are any questions, I'm open to that. Well, if not, I thank you very much.
Hi. Thank you very much. Yeah, I see still some
Hi.
students, they are trying to join us. Can you hear me? Okay. Okay, I hope you can hear me.
I can't hear you very well, sorry.
Okay. I tried to put a microphone. Maybe it's...
Yeah, it's cutting. I don't know why.
Better now? Can you hear me much better? Okay.
Okay. Thank you for...
Ask the students if you vous avez des questions.
I changed the... Sorry, sorry, I mean, I still can't hear you. But I thank you very much for... Okay, please, go ahead with the chat. And I'm sorry, I'm really having a problem. Let me just, I'm trying to change the audio. Okay. Mas you can talk, you can type on the chat, no problem. Thank you. If you want to place your question, go ahead. Okay. Okay, Philippe, just a second. Anti-corruption layer is the best way to migrate from anti-corruption. I'm not really sure. You mean corruption like security and things like that? Is that right? Yeah, well, that's definitely an issue. I mean, uh, when you break things, you expose these things. Of course, that when you design microservices, you have all the security, encryption, everything. You're gonna put everything you can, but you also there's no way you do not the opposite. I mean, you're always gonna get more exposed. So yeah, you have to put these layers of security there if that's what you need. You see, it's not the question of uh, best way. I mean, if your microservice, if your business logic there requires a high level of security, you have two choices. One is surround with a very strong security layer, or not migrate to microservices at all. You know, if you think, for example, election, well, I can say in Brazil, everything in Brazil, our elections are um, electronic, and the solution for security is there is no connection with the network, and that's it. You know, everything is closer to a box and there is no wire. And so depending on your what is your problem, perhaps um, a good security encryption, etc., solve your problem. And perhaps you could choose not to migrate to microservices at all. Okay. Um, Based on our experience, what have been the biggest lessons learned in transitions from monolithic architectures of the eights to the Microsoft and service architectures? Okay, I'm gonna tell you this, and uh, this is new. Okay, Microsoft's microservices, it's something new. In terms of technology, 1, 2, 3 years is yesterday. A good technology is just to begin to be solid after 10 years. You know, a lot of things, there is a lot of open, let's say, open questions there. One of them I just told you. Um, Database is a real challenge because the idea of create microservices where um, each microservice has its own part of the database separate, it violates a lot of uh, data modeling and database principles, you know. So my experience with that so far is that the challenge is how much you're going to sever your system um, to, in a way that you're going to benefit from the microservices, but not destroy, let's say, the original consistency of your original system. Let me give you an example. If I have what's usual, if I have a monolithic systems where I have centralized database that does a lot of data warehousing, for example, gets data from several places and transforms them and processes them in something more unified. If I want to break this guy, it's more likely that the business rules that are inserted in the database will be duplicated because the the microservices will have business rules that are in the database and are in the code, and the other side the same, and they interact. So it's a challenge, you know. You have the risk of having the same business logic in two places. And this is a real problem, because if you forget to update in one place in the other, well, and you imagine the consequences. So I think today my point of view is that microservices is not, for example, for database intense connections. I think microservices is very useful for example, machine learning, for algorithm and process intense systems that I have to put in a big machine, and they are completely self-contained, you know. So my experience goes on that direction. Okay. Between, well, Philip, okay, I'm reading. Look, I think I can't give you a good answer right now. I do not know on your architecture in deep to give you a good answer, but I'm going back what I said before. These architectures are the focus is business logic. So if your business, if your problem is strong business logic oriented, you go with that, because you have a very complicated business logic to protect. I could imagine, for example, let's say some proprietary algorithm of artificial intelligence, of I don't know, some of these large language models, or an algorithm for strategic military analysis, you know, strategic, you know, war and stuff. I imagine that these algorithms, these strategic algorithms, are extremely secret, extremely important, and you should not mess with them, and they should be protected. So maybe you should open, you should give up some other criteria, because this criteria is more important. The rule of thumb, you may have heard about this expression, is there is no free lunch. You know, you have to open. You know, you have to let it go some stuff in order to prioritize what's more important. Okay, Irene. In startup IT projects and new brand project, I would not say that, Irene. I would not say that. Uh, kind of depends on the project. Again, I would go with microservices. Well, of course, there is a question of academic, I mean, like a learning purpose. So sometimes we should advise to use, because they have to understand how it works. But it would be interesting if the project had a real need. So I do not know the startup project you are working, but I would focus. You don't have to do microservices for everything. You can do just a small piece. So it's focused on things related to complex algorithms. I would say if there is some machine learning, to use that. Well, yes, you have to actually. This is not new. That first project I just told you we were beginning to use one IBM project for business orchestration, and and um, uh, and we gave up at that time because the product was, as we used to say, the project was not kind of ready for prime time. It was not good enough. Today we have Kubernetes, we have several orchestration products, very good products, and I have no problems with that. And I would just say it's my philosophy that um, you don't overuse, you don't use something that we don't really need. I think it's important to understand the need for the things. So orchestration is very good, mainly if you need an automation and, several things to make sure that a process is done. Let's see, well, if I put my credit card, I put my password in some machine to pay something, I would like an orchestration process that sends a message to me at the same time saying, look, the guy, the value on that small machine is the exactly value that was charged in your account. That's a process that I would like to be orchestrated, and that would be interesting. So again, you always pay some performance with orchestration, of course, but it may worth it if the business logic, if the business, the requirements supports that. Wow, that's a very, you are welcome with, um, oh, that's a good question, Philippe. Um, well, here is the thing. My mentor used to say the same thing to me, and that is a good architect has been a good developer first, okay? Because sometimes it's, if you never implemented that thing, if you never saw that working really, it's difficult to you, it will begin to be so abstract for you, just a box. So, but doesn't mean that you need to be a specialist. So let me give you an example. Let's say, for example, you are an architect, you have to design um, a cloud architecture that will connect to a database, and then you send data to a machine learning algorithm, and you send the data to um, and there is some uh, business console where people are going to do analysis, okay? You don't necessarily need to implement all that stuff by yourself to be a good cloud architect. But I would advise, okay, let me do a kind of hello world here. Let me see if I can connect to an RDS, for example. That's the relational data service for AWS. Let me see if I can create one example here and there. So you have to understand, you have to put your hands dirty a little bit and see things working and really understand how that thing is working. Oh, okay. Now I understand how it's working. Now, now you can move to a more architect position because you know how things are working. And the other advice is certifications is a good thing. The TOGAF architecture is a very recognizable because it's international and it crosses borders. I mean, it's not an AWS certification, it's not an Azure certification. It's a certification that you have the knowledge, the full knowledge to be an architect. So that's an advice I would give you, is follow these lines. Yeah. Uh, the fact is, IT architect certification is partnered with the TOGAF Open Group One. So when you get one, they actually kind of get you the other. If you are working for IBM, as I was, I got the IBM one and I got the Open Group One together. If you are not working for IBM, you can do the certification not working for them, but you also can do the external one. So both are very good, Philips. If you want to do both, I encourage you. Anything else?
I don't think some question. Yeah.
Okay. So I thank you all very much for your questions.